right, the last thing we're going to talk about here is expected value. Now, again, in statistics, words make an impact. So expected value is the mean of the discrete random variable. And how do we find that mean? Remember, whenever we did the mean, so I'm going to flip back just a second. Over here to this mean, that is multiply them together and add up the options. You could do that by hand. We could do that on StatCrunch. That's what we just talked about. So an expected value, this is just words that you can use to put with, as soon as you see expected value or what is expected, then you know automatically you're looking for the mean. All right, that's the key. But it's a discrete random variable, so you have to have those two columns. You have to have your x and your probability of x. So that's the key. All right, so let's look at how this plays out. Here we have a term life insurance policy will pay a beneficiary a certain sum of money upon the death of a policyholder. These policies have premiums that must be paid annually. Suppose an 18-year-old male buys a $250,000 one-year term life policy for $350. According to the National Vital Statistics Report, those volumes in that number, the probability that a male will survive is 0.998937. Here's those words. Compute the expected value of this policy to the insurance company. So that's what we're trying to figure out, all right? So here's the deal. We have two outcomes. Throughout the year, this gentleman can survive, and we have its probability, or he could not, right? He would die. Those are the two outcomes that are possible. So we want to figure out what's the probability this 18-year-old male will survive, and what's the probability this 18-year-old male could die. I know this is so morbid. And this is tough, but this is statistics. This is a lot of insurance stuff. Policies are made this way. Scholarships are given this way. Statistics is a very useful form of math. So, what is the probability that this gentleman will make it? 0.998937. So real good, right? Real good is what we're looking at. So then how do I figure out the probability that he could die? That's the complement. Yes, because it's the other side. Oh, my pencil's not playing nice. That will be the complement. So I'm going to do 1 minus 0.998937, and you get 0.001063. So that's the probability that he's not going to make it. All right, so let me make this bigger so we can see it better. With that complement, I wanted to get that in there. Now, here's the thing. Our whole goal here is we want to compute the expected value of the insurance company. Well, here's the deal. They're paying $350 for 1 year. So how much does the insurance company get if he survives that year? Yep, they will get the $350 because they're paying for that, right? What happens if he does not make it? If he dies, what happens to, what is the insurance company paying? They're paying that $250, right? So then this means they have to pay the $250,000 less the $350 that they paid in for the policy. Do you see what happened there? Okay, so then that means they actually have the $350 that it was a positive minus the $250,000. The insurance company is negative $249,650. So these are the two choices. They're either going to make $350, right, on the high probability that this guy will survive, or they're going to be out $249,650 on this low probability that he doesn't make it. That's life insurance. That's why you get these policies, right, that pay out so much because you're paying in every year for these policies. Okay, so look at what's happening here. Let's make our own chart. So here we're going to say if he survives or doesn't. So X here, our option is $350 with the probability of 0.998937 because we're looking at the expected value of that insurance policy. How much is the insurance company going to make on this? All right, expected value of the policy to the insurance company. All right, or if he dies, it's negative 249,650, and the probability that will happen is 0.001063. All right. Okay, now we're back to the same table like we had with the free throws. The key to this problem, and the people always ask about this, the key to this problem is you have to figure out the probabilities. You're given one of them, so you have to get the complement for the other. And you have to say how much is the payout because that's the value that we're going for. So you have to figure those pieces out. Once you have this figured out, then it's just a matter of plugging it back in, right? So I'm going to scoot this over a little bit. I didn't have these plugged into StatCrunch already. Oh, I can't see that. So I was hoping I could see, oops, both of those on there, but I can't. So it's 350 and negative 249,650, where variable 2 is 0.998937, and the probability of dying is 0.001063. Then the same thing, right? Did you remember it? Stat, calculator, custom, variable 1, variable 2, and compute it. And there it is. If I want the mean, which expected value is mean, I don't care about standard deviation for this one. My expected value here is the mean. So let me get my iPad back over here so we can write it in. The mean of this, I don't know. Oops, that's not helpful, is it? The mean is 84.25. Let me scoot this over so you can see the whole thing. Our mean is $84.25. The insurance company will make $84.25 per year. The company will make $84.25 per year for each 18-year-old male they insure. It's a numbers game, right? So for the year, they're really only expected to make $84.25. They're still in the good. Even if they have to pay out, because the probability that they pay out is so low, they're still to the positive. And that's how this price was come up with, right? If I'm paying $350, if they made it $250, that'll affect how much they have to make each year, right? How much they need to make. Okay, so it's a numbers game. The more you insure, the more money you make. That's how that goes. Now, just as a side note here, I'm going to scoot this up so we can see this part. I want you to see what this looks like by hand. Now, on the other one where we were trying to do those big, huge numbers and the huge quantity of it, it made more of an impact. But for this one, because it's not very much, then I'm going to sum this up where I have x times p of x. That makes it easier. So I'm looking at 350 times 0.998937 plus negative 249,650 times 0.001063. Literally, that's it. You multiply those together and you add them up. Because I'm only at 2 pieces of info, it's pretty easy to see what it is. And now check your answer. Is it the same? Yeah, because that's what StatCrunch does. It just does the calculations for you. You still have to know what it is. To compute a mean by hand, because there's only 2 of them here, sometimes I just pull my calculator out and do work on it because it's just as easy. It's only a couple of things. So it's up to you, however you want to pull that off. Whether you want to go through StatCrunch or if you're just finding the mean. Now, standard deviation, you have to do in StatCrunch. But here, if you're just finding the mean, sometimes it's easier just to use your calculator. Pretty cool, right?